finishing chapter 4. So welcome back to class number 2. Yesterday, if you guys were here, we talked about concentration. And there's 3 ways today that we're going to look at calculating concentration. We're going to look at the chemistry way, molarity, which, most chemistry students in the world, well, I say most, every chemistry student in the world dealing with concentration knows how to do, or at least learns how to do. And then we'll get into ones that I didn't use a lot in my education because I wasn't in engineering or medical science. I just did basic or general chemistry. You guys might be more interested in the last 2. So my engineers in here or medical science students, typically concentrations in those industries can be represented as a percentage or parts per million. One thing I want to explain, and I kind of didn't do a very good job of this in the first class, so you guys are a little lucky. These are the same. The only difference between mass percent and parts per million is the number you multiply them by at the end. And I'm going to get into this a little later, but just a little heads up, I guess, is these 2 are the same. The only difference is for percent, we multiply them by 100% to turn it into a percentage. And for parts per million, you multiply it by 1,000,000. Oops, sorry, I dropped my pen. 10 to the power of 6 is 1,000,000. So 1 with 6 zeros after it. So 1,000,000. All of these formulas are in your data booklet. Okay, they're on page 9 in your data booklet. So let's get started. The first formula I gave to you yesterday, and this is about as far as we got, is that in chemistry, we calculate concentration as molarity. And molarity is moles per liter of solution. That's really important. It's different than percentages or parts per million. So we would take the moles of our solute and divide it by the liters of the solution. So moles of solute over liters of solution. The key word there is solution, meaning it's not the solvent, it's the final total amount of volume that we have. And we're going to do this in lab number 9. So let's look at a very quick and easy example. And then we'll do a much harder, well, harder is not really a good thing to say, a much more detailed question where there's multiple steps. So this type of question is very easy. This would be a good kind of multiple choice type question, wink, wink, where it's really only 1 step or maybe 1.5 steps. The question says, what is the concentration or what is the molarity of a solution containing 2.5 or 2.5 moles? So there's my moles, and 500 milliliters of solution. That's my volume. Now, the reason I say that there's 1.5 steps is there's one extra thing we need to do before I can do this question. Molarity is moles over liters. And you'll notice that this number is not in liters. So the first thing I need to do is change this into liters. And I do that by dividing by 1,000. And I'm going to give you a little rundown of unit conversions in the next section. In physics and math, unit conversions can be a very big deal. And they certainly are in chemistry. But in 1120, we're only going to deal with a few unit conversions. And again, when I say unit conversion, I mean going from like grams to kilograms or milliliters to liters. So this is the first one you need to know. To change milliliters to liters, I divide by 1,000. Technically, I'm multiplying it by 10 to the power of -3, but I'm just dividing it by 1,000. So I put in my numbers. I notice that I've changed this to liters, and you get your concentration. Pretty easy concept, a good multiple choice, just one quick step, moles divided by volume. This question, this is slide 61. This is a very good question, and we're going to take our time to solve this one. I love this question. You will definitely be expected to know how to do a question like this. There are worksheets on this, by the way, with answers. So if you guys want to try some of the worksheets in chapter 4, they're on D2L if you really want to practice this. Okay, so let's break this question down into pieces. First things first, it's asking for, technically, this question should be saying, what is the molarity of a solution that contains 5.45 grams, all right, so we have our mass of sodium chloride. That's going to come back to us. That's going to be really important in a minute. Dissolved in 460 milliliters of solution. So this is our total solution. So okay, there's multiple steps to this question. Arguably, there are two major steps, and Iman has outlined in the chat the first step. The first major step is to calculate moles, N. I cannot solve this equation if I don't know moles. Luckily, we learned in chapter 4 a couple weeks ago, or no, a couple classes ago, that if you're given the mass of a compound, you can easily find the moles. So step number 1, just as Aman said, I'm going to find the moles of my chemical by taking the mass and dividing it by the molar mass of that chemical. So 5.45 grams divided by my molar mass. Now, for my molar mass, I need to do a little bit of work. This is where some of the little intricate steps come into play. Again, I mentioned that this is basically a 2-step problem, but there are little minor corrections we need to make as we go through this. And the first one is, what is the molar mass of NaCl? Well, to do that, I add together the mass of Na, sodium, 989,769. That's sodium. And I'm going to add that to chlorine, 35.453. And the units for this are grams per mole. Now, I'm going a little fast through this step, step number 1, because we did step number 1 a few classes ago. This is definitely something you need to know how to do, how to calculate moles. So I have brought home from work my calculator, and I'm just putting all of this in on my calculator using brackets to make sure everything is okay. And I get 0.093254324 moles of solution. Moles of solute, I guess is what I should say. Now, little discussion about significant figures before I move on. Remember the hint I gave you a week ago, or 3 or 4 classes ago. The easiest way to answer significant figures in chemistry is to look at the problem, look at the question, find the lowest number of significant figures, it would be 3, and just make sure your answer has 3 significant figures. Now, some of you guys might be thinking, well, hold up, you have written, 5 significant figures here. Well, I don't want to round yet. You only round to 3 significant figures at the very end. So I'm going to do that at the very end. And as Aman said, yeah, you use the hint in the lab 7 quiz. That's good, because that's basically what will get you the correct answer in lab 7. Okay, so step number 2. Step number 2 also has a hidden kind of calculation in it for you guys to get full marks. So I'm going to do step 2 in blue. Step 2, answer the question. right? Concentration or molarity is moles of solute over volume of solution. So I take my moles, 0.093254. Moles. And I divide it by the volume. Now, the next part. So this would probably be worth 3 marks. You would get half of a mark for calculating molar mass. You would get half of a mark for the next step, which is what I'm going to show you, and then a mark each for calculating moles and then finding the answer. I cannot write 467 milliliters here. Nope. Concentration, or sorry, molarity in chemistry is always in moles per liter. So I need to change the milliliters to liters. And remember, all I need to do is divide by 1,000. So that's it. This is a pretty easy question. Obviously, if you know your formulas, and all of these formulas are given in your data booklet. So my answer, I'm rounding to 3 decimal places, is 0.200 moles per liter. What my calculator is actually saying is my calculator is saying 0.19968, but when I round up, it becomes 0.200. And I wouldn't stress too much about significant figures or perfect rounding. I mean, if you guys want to get 100%, you need to be perfect, meaning I'll be looking for correct rounding, proper significant figures, but I wouldn't stress too much, because if you were doing this on your final exam or even your like an assignment or quiz or something, it's not worth very much. But it is important if you guys want to get that beautiful 100%. I do actually have a few students in this section and the other section who have gotten 100% on assessments. So there are people out there who want that 100%. All right, that's it. That's molarity. Now, here's my plan for today, like time depending, we'll see, because I do have to leave a little early for my lab. But I would like to show you the next 2 ways to calculate concentration. And then tomorrow on Wednesday's class, we'll do a little extra practice on this and then start chapter 5. So if anybody's feeling, after this class, they don't know what to do, we'll do a little bit of practice with this tomorrow afternoon or tomorrow morning, depending on what time our class is. I think your class is tomorrow afternoon. Okay, so let me just kind of quickly move into the next 2 types. I'll show you some examples and we will practice this tomorrow. All right, so the next type of concentration, it's percent concentration. This is in your data booklet. This formula. Okay, so the way percent concentration is you take, now for the percent, it can be in mass, it can be in volume. It really doesn't change how we calculate this. It's the mass of the solute divided by the total mass of the solution, that's key, times by 100%. Okay, that's it. So the mass of the solute divided by the entire mass of the system. So the mass of the solution would include the solute and the solvent, the total mass. So you divide those 2 numbers and then multiply by 100. It's literally like how you guys would calculate what you got on a test, right? a percent is defined as the part of something over the whole amount. So if you guys on a test say you got 6 questions right out of a possible 10, the part of the questions you got right is 6. The total amount of questions, the whole amount, is 10. So you would say you got a 60%. You would calculate that, and I'm assuming you all know how to do this. I hope you do. Divide 6 by 10, so 6 divided by 10, and then multiply by 100. A lot of times when I give you your grade, I'll be like, oh, 12.6 out of 14.5, and then you guys have to calculate your own percent. So you should be pretty familiar with calculating percents. So let's look at a couple of examples. So what if I told you, and again, like, don't think too hard about this. This is a really kind of simple concept. If I told you you had 5 grams of solute, so this could be sodium chloride, it could be, sugar, glucose, fructose, whatever. You had 5 grams of that, and it was in 50 grams total of solution. This is the equivalent of you getting 5 marks out of 50 on a test, and I just want you to calculate the percent. What percent of this solution is the solute? So I take my 5 grams, I divide it by the entire mass of the solution, sorry, and I multiply by 100%, and I get 10%, and that's it. This W over W represents that it's mass over mass. You don't need to worry about that. That's not something we're going to worry about in chemistry 1120. But sometimes when you see this represented in real life, you might see like M over M or W over W, meaning that it's a mass relationship. Not important. All you guys need to know is that it's 10%. So 10% of this solution is solute. Typically, industry uses percent concentration for large concentrations. And I would consider, in a chemistry way, this is a pretty large concentration. Typically in chemistry, we deal with very small amounts or small concentrations. So this is, considered pretty big. Okay, what if I give you like a volume? Okay, what if I say that a solution contains 4 grams of solute in 35 milliliters of solution? Well, one thing to keep in mind is that the density of water is 1 gram per milliliter. So for these types of calculations, excuse me, we can interchange grams and milliliters, meaning they represent the same thing. So if I want to find this answer, it's the exact same calculation. It's 4 divided by 35 times 100. 4 divided by 35 times 100. Notice there's no units for this. It's just percent. So 35 milliliters is equal to 35 grams. So again, and you don't even really need to worry about the units. You just need to make sure that you divide them, the grams of the solute, or the 4 grams of the solute by the 35 milliliters of solution. You can divide that out and you will get 11%. It's a pretty simple procedure. The only thing, and you'll see this in the next question, the only thing you really need to keep or be careful about is that you are given the solution's mass or volume. And I'm going to explain why this is a problem on the next slide. And by the way, we will practice this tomorrow. So tomorrow, I'll give you a couple problems that we can do together to practice this. This is a tough question. If this was a multiple choice, this would be considered a tricky or challenging multiple choice. Why is it challenging? You really need to read what the question is saying. So I have a solution that has 5 milliliters of solute. Again, and milliliters and grams are interchangeable. It doesn't matter. As long as I have milliliters or grams, it's okay. I can use the same numbers. So as long as there's milliliters or grams, I'm good to go. And Iman basically answers the question in the chat I was getting to, is the word says solvent over here. So let me explain. We have 5 milliliters of solute, and I'm going to add that to 50 milliliters of solvent. So the question you need to ask yourself is, what is the total amount? Right? What is the solution? And it's pretty easy. If you took 5 grams of something and added it, or even 5 milliliters of something, and added it to 50 milliliters or 50 grams of something, you would have 55 total things. I said that kind of weird, but you know what I mean. If you mix together 5 grams and 50 grams, your total amount would be 55. If you mix 5 milliliters and 50 milliliters, your total amount would be 55 milliliters. So the workings for this, I'm just going to erase my writing here. And you don't even need to worry about changing it to mass. You can if you want to. But what you need to do is first you need to find the total amount of solution. And my total amount is 55. So now I'm ready to go. And again, Aman in the chat has answered this perfectly. It's 5.0 divided by not 50, divided by 55, because the key is that it's your solution on the bottom. And guys, for molarity, for percents, for ppm, for any type of these calculations, the bottom has to be your total solution. So 5 divided by 55 gives me 9.1. And the V over V, don't worry about it. It means volume divided by volume, but you don't have to worry about that. So it's 9.1. This type of calculation, volume and volume, is usually used for liquids in industry. Oops, I didn't mean to skip ahead there. So we use this a lot in the engineering industry. Yes, Iman, do you have a question? Okay, that's a really good question. So Aman asked in the chat, I don't know if you guys are in the chat. In the test, do we have to show you that we change milliliters to grams? Absolutely not. You don't even need to show me these units because the units always cancel. You'll notice there's no units for these questions. So you don't have to show me the changing milliliters to, or sorry, grams to milliliters, milliliters to grams. All you truly need to do is to take the amount, it can be milliliters or grams, it doesn't matter. Take the amount of solute and divide it by the total amount of solution. Grams and milliliters do not matter. Good question, very good question. Okay, again, it might seem like I'm just kind of going quick through this. I guess I kind of am. It's what my goal for today is to show you these calculations, and then tomorrow we'll do some practice problems. We will have to start chapter 5 tomorrow, but I will show you some practice problems. Okay, the finale of today, and I don't know if I'll get through both problems, but I'm going to at least show you the first one. And there's a little kind of, I guess cheat sheet's not the right word, but I'm going to give you a little bit of information that you must remember for tests or final exams about unit conversion on the next slide. So just give me a couple more minutes because I'm going to share with you some pretty important information. Parts per million is our last form of concentration. This is concentration typically used for very, very, very weak solutions. It's dilute, meaning small concentrations. And when I say small, I mean like incredibly small. So a situation where you might use parts per million would be like taking 1 grain of salt. So pour some salt out in your hand. Take 1 crystal and drop it in a bucket of water. That would be a situation where we use parts per million. We typically use parts per million when testing water quality because, if you look at the ocean or a river or a lake, there's an amazing, incredible amount of water, and the solute dissolved in that is very small. Now, ppm is technically represented by 1 kilogram of solution over 1 milligram of solute. And I'm going to explain how you guys calculate that in a second. This is the same method as percent. The only difference is we multiply it by 10 to the power of 6, not 100. Okay, that's the only difference for parts per million compared to percents. So let me explain, let me show you a problem. Okay, and this can be, this is about as challenging as they get. A solution which contains 5 milligrams of solute in 5 kilograms of solution has a concentration of what? Now, I told you that parts per million is literally defined as milligrams of solute over kilograms of solution. So I know the answer here is 1 parts per million. But I'd like for you guys, or it might help you guys, to be consistent in your calculations. And I told you this is the same as percent calculations. So what I want to do is I want to change these numbers to grams. And it doesn't make much sense for this question to change into grams, but it is definitely the best way to think about this going forward, because this allows you to use the formula in your data booklet. So when we're dealing with percent concentration, you know, we always use grams. Okay, you can see that in these examples here. Sorry for all the mess, but we always use grams. And a milliliter is a gram. So I want to keep consistent. I want to use grams. Oops, I didn't mean to show you that. So this brings me to unit conversions. You can get by in chemistry with 3 unit conversions. To go from milliliters to liters, you divide by 1,000. To go from milligrams to grams, guess what? Same thing, divide by 1,000. And the only other one that you truly need to know to get by in chemistry is kilograms to grams. You would multiply by 1,000. If you know those 3 unit conversions, you will get by in chemistry 1120. So milliliters or milligrams to liters or grams, we divide by 1,000. Kilograms to grams, you multiply by 1,000. Technically, you guys should have done this in math or physics. So you probably have seen this before. Now, some of you might not be in physics. Some of you might not have done math yet, but you need to memorize those 3 things. Yes. Oh, that's a really another good question, Aman. The question was, will it tell us to find ppm? Yes. This is maybe not the best question, because on a test, I will say, you know, find the concentration in percent, find the concentration in molarity, or find the concentration in ppm. Thank you. That's a really good question, because on a test, I will have to tell you, do I want percent? Do I want molarity, or do I want ppm? So what I do is I follow this formula in your data booklet. This is straight from your data booklet. I take the 5 milligrams and 5 kilograms. I convert them to grams and then multiply by 10 to the 6. Now, this over here might look a little confusing. 5 milligrams is 0.0050 grams, and 5 kilograms is 5,000 grams. So what I'm doing here, these numbers, and I'm sorry if that's confusing, it's this. I divided milligrams by 1,000, I multiplied kilograms by 1,000, and then I multiply that number by 10 to the 6. So if this was a percent question, I would multiply it by 100%, but it is not. It's a ppm question. So I multiply it by 10 to the 6, and I get my answer, 1 parts per million. All right. Let me just check the chat. Perfect. Okay. So guys, I'm going to leave it here because I got to head out to get to the lab. This question and practice, there we go. This question plus some practice questions we'll do tomorrow afternoon in class. Okay, so if any of you guys are feeling, this is a bit much, or you don't know what is going on, you don't know how you would possibly do this, tomorrow we will practice all of this, and we will complete this question here on the last slide. You'll notice this is the end of the PowerPoint, and then we get to go to chapter 5. Exciting. There's only 2 chapters left, and chapter 6 especially is one of the shortest chapters in this whole course. So we're very close to the end here. So guys, I'm going to hit stop record. If you have any questions after that, you can let me know. But other than that, we're done. There was a question from someone earlier about the Lab 7. You can ask that now, but you are free to go. So thanks, everybody. Have a great day. Be safe.